Hey everyone, it's Ethan Teaches Maths, and today I'm going to teach you how to integrate pure 2 standard functions. So pure 2 is if you're in year 13 and you're doing A-level maths, we introduce you to some new methods to integrate some more complex functions. In this video, I'm going to go over the most basic ones, which are just, as you can see on the screen. Okay, so how do we integrate these things? Well, right now, you have no clue. The only way you could potentially do the one on the left-hand side is expand the power and integrate each term individually. But that's not going to be great when there's a power of 13. You don't want to expand a 13 bracket. That's going to take a really long time. So what do you do? How do you overcome that? So the way you do it is you do it via a method, and the method which we're going to use, I call it the fudge factor method. Okay, so what is the fudge factor method all about? So when you integrate, and you've known this for a whole year in year 12, you increase the power by 1 and you divide by the new power. That's it. So what we're going to do is we're going to let y equal x plus 3 to the power of 4. Why? Because when you integrate, you increase the power by 1, right? So 3 is going to go to a 4. But we're not going to divide by the new power just yet. And to think about that, we have to be really good at differentiation. In particular, we have to know the chain rule like it's the back of our hand. So, as you know, differentiation is the opposite of integration. One is the opposite of the other. So if we differentiate this function of y, then we need to use a chain rule, which I'm going to assume you know how to do. I'm not going to explain the chain rule. I'm just going to do it. So the power comes to the front, you differentiate the thing in the bracket, and you decrease the power by 1. If you want more information on how to do the chain rule, leave a comment below, and I'll be more than happy to do a video about the chain rule. Okay. So what have we done so far? All we've done is we guess what the integral is going to be. How do we guess? Well, we just increase the power by 1 because that's what integration is all about. And then we differentiated this thing here. Why do we differentiate it? Because integration is the opposite of differentiation. And in theory, if we differentiate this, we should get back to this. Why? Because one is the opposite of the other. That's a really important thing to remember. Integration and differentiation are opposites to each other. So, is that true? When we differentiate the function y, do we get this integral? Well, not quite. There's a 4 outside the brackets, and I call that the fudge factor. Okay, so let me highlight some stuff here. So we have 4 is here, but there is no 4 there. So what do? Well, to counteract that, we use a fudge factor to cancel out the 4, and the fudge factor is going to be a quarter. So the integral of this is going to be a quarter x plus 3 to the power of 4. Now, why is it a quarter? Why is a quarter a fudge factor? Well, just think about it. If we guess that the integral was a quarter x plus 3 to the power of 4, then when we differentiate that by using the chain rule, we get the power, we move it to the front, which is the shortcut of the chain rule, which I'm assuming you know, and that would be a 4 times a quarter, and that would magically disappear, leaving us with the original integral. Okay, so that's the main gist of it. Let's see another example. So on the right-hand side, we'll call it question 2. We have another integral, and in this case, you wouldn't be able to expand the power because it's a negative power. So what do? Well, we use the fudge factor method. So first step 1, we need to guess what the integral is going to be. And the way we guess is simply, we just increase the power by 1. So minus 5 plus 1 is minus 4. Easy. All right, and now we're going to differentiate it. Why do we differentiate it? We differentiate it to see if when we differentiate it, is it the same as the original question, because they should be opposites of each other. Okay, so let's differentiate it. I'm going to move the power to the front. I'm going to differentiate the thing in the bracket. I'm going to decrease the power by 1. And notice how when I'm decreasing the power by 1, it's not a surprise. It is the power of the original integral, because we're getting back to that. So just doing some algebra, so I get 8 and then 7 minus 2x power of minus 5. Now, what do we do now? Well, we check, is there an 8 over here? And there's not an 8, unfortunately for us. So how do we kind of overcome that? What do we do? Well, we use a fudge factor. Can you guess what the fudge factor is going to be? It's not going to be 8, it's going to be an 8th. An 8th of what? An 8th of the thing that we guessed the integral is going to be. Why? Because if we had an 8th here, it would have carried down to here, would have carried down to here, and then you could have seen the cancellation happening over there. Okay, so that's the fudge factor method, where an 8th is the fudge factor. And the fudge factor method works for loads of standard results in integration, not just these basic ones. Okay, I'm going to do some special cases. So what do I mean by special cases? Well, when things don't go to plan. So how do we integrate 1 over x minus 3? Okay, so let's rewrite that as a fractional power to begin with. All right, then what was the fudge factor method? Well, the fudge factor method, I've been telling you multiple times in the video, you need to guess. You guess what the integral is. How do you guess what the integral is? You increase the power by 1, because that's how you integrate. All right, so what's minus 1 plus 1? Oh no, that's not going to work then, is it? Because anything for power of 0 is 1. So that is absolute gibberish. That's not going to help us at all. I did that to show you what would happen if you tried to use the method which we just did before. In order to integrate something which looks like 1 over x, where the bottom of the fraction, the denominator, has a power of 1, or the degree of x is 1, then you need to use logs. Okay, so we wouldn't guess the integral is you increase the power by 1. Here we would guess the integral is log or ln of the denominator. Why? Because if we differentiate that, then how do we integrate logs? Well, I'm assuming you know how to differentiate logs. It's function, I'm going to write it here, the function goes underneath the derivative. And what do I mean by the function? The function is, of course, the thing in the brackets, and the derivative is what happens when you differentiate the thing in the brackets. So let's make that crystal clear. The derivative is going to be 1, and the function is going to be x minus 3. So in this case, it's easy. There is no fudge factor. It's just ln of x minus 3. Of course, I should be writing plus c every time, but yeah, I don't care. It's fine. So how do we know we got it correct? Well, one is the opposite of the other. So happy days. Right, last one. 3 over 1 minus 4x. So again, we can see the power on the denominator is a 1. So if we try and do it using the fudge factor method over here, it's going to turn out the same as the other one, where the power was a 0. That would be no good. We have to apply logs. So what do? Well, we guess. We guess that the integral is going to be log, and then I'm not going to use modular signs, I'm just going to use brackets. Log 1 minus 4x. Okay, cool. I'm going to differentiate that. So I get the function goes under the derivative. So what is the derivative of the thing in the brackets? So 1 minus 4x, that's just minus 4. and function is 1 minus 4x. Okay, now we need to use a fudge factor. Why do we need to use a fudge factor? Well, there's a 3 here, and there's a minus 4 here. Clearly, they're not the same. So what do? Where's the fudge factor? Can you figure it out? Okay, so it's very, very simple. The fudge factor is going to be minus 3/4. So the answer is going to be minus 3/4 log 1 minus 4x. Where the hell did minus 3/4 come from? Great question. All right, so minus 3/4 came from the fact that there was no minus 4 on top here, and there wasn't a 3 on the numerator here. So by putting in a fudge factor of minus 3/4, it would cancel out the minus 4. The minus 1/4 would definitely cancel out the minus 4 because there's cancellation going on there. And then if we had a 3 on top, well, that's really good because the 4s would cancel out and the minus would disappear and the 3 would stay on top. And that's exactly what we wanted. All right, so if you've got any questions on this, leave it in the comments. And of course, if you want private tuition with me, check my website, ethanteachesmath.com. I'll see you next time.